When trying to solve a second-order linear differential equation, one that's non-homogenous like this, that means on the right-hand side it's not equal to 0, and it's second order because it involves the second derivative, what we need to do is to find two things. We need to find the complementary function and the particular integral. So we're going to use the left-hand side of the equation to find the complementary function. So we're going to find and we're going to use the right-hand side of the equation to help us to find the particular integral. And we're then going to find the solution by saying y is equal to the sum of YCF plus YPI. So we're going to add the complementary function, which is the general solution, with the particular integral. Now, the complementary function is essentially the general solution that we find from the left-hand side of this differential equation. So because it's a second-order differential equation, then we need to write something that we call the auxiliary equation. And that's going to be a quadratic equation. We use the coefficients 1, 6, and 9 from the differential equation. So we end up with lambda squared plus 6 lambda plus 9 equals 0. So we're only looking at the left-hand side of the equation. We solve that to find lambda. In this case, I'm going to try to factorize it. So lambda plus 3 squared equals 0. So that gives us lambda equals -3. And this is what we call repeated roots. So the two roots are equal. So we call them repeated roots. So in this case, our complementary function, or our general solution, will have the form a plus bx times e to the lambda x. So in this case, where lambda is -3, we can write our complementary function, our general solution, as y equals a plus bx, where a and b are constants that we don't know, times e to the -3x. The next thing we need to do is to find YPI, or the particular integral. And we'll do that by looking at the right-hand side of the equation. So because we have a linear expression, we have -9x plus 12, we can assume that YPI will have a linear form. So let's say it looks like something in the form cx plus d, or c and d are constants, but they're constants we need to find because this is the particular integral, the specific solution. So let's find the first and second derivatives of YPI. So y pi dash, our first derivative, is simply c, and the second derivative of a constant is 0. So now we know the first and second derivatives. We can plug those back into our differential equation. So if we look at the original equation here, and we plug these in, they should equal minus 9x plus 12. So the second derivative is 0, so that's that. So that's 0 plus 6 times the first derivative, which is c, plus 9 times y, which is cx plus d, is equal to minus 9x plus 12. So that should be enough for us to solve for c and d. So if we simplify that, that gives me 6c plus 9cx plus 9d equals negative 9x plus 12. And if we simply look at the coefficients, I can rearrange this to make it look like this. 9c times x plus 6c plus 9d equals minus 9x plus 12. And if we simply look at the coefficients, it looks like we can say that 9c has to equal negative 9 because that's the coefficient of x. And there's only one x on both sides of the equation. So we can say 9c is minus 9x. So c is negative 1. So that's really helpful. Now we know the value for c. We can substitute that into there and find d. So I'll now rewrite the equation, or actually I will look at the coefficients or we'll look at the number that doesn't have an x attached to it. So we've got 9c, also 6c plus 9d, and that's got to be equal to 12. So that allows me to write another equation. So I can say 6 times c plus 9d, so that's this bit, has to be equal to 12, which is that bit. And because I already know that c is negative 1, I can substitute that negative 1 in there and solve for d. So I have 6 times negative 1 plus 9d equals 12. So negative 6 plus 9d is 12. 9d is 12 plus 6, 18. d equals 2. So now we know d and c, we can write the expression for the particular integral. So ypi, because we know c and d, we can write that out as such. So we can put the values that we just found. So the d goes in there, and the c that we found goes in there. So my ypi, my particular integral, my specific solution, is negative x plus 2. Now that's really helpful because now I can write my final answer as the sum of the complementary function and the particular integral. So I can say my final answer is the sum of this, which goes into ypi, and this, which was my YCF. So I'll copy this so that we have it down here. And this goes into there. So my final solution, my final answer, will look something like this. Y equals unknown constants a plus bx times e to the minus 3x minus x plus 2. Now that is now the final answer for the solution for a second order linear non-homogeneous differential equation. So we found it by finding the complementary function, or the general solution, plus the particular integral. We did these separately. We used the left-hand side to find the complementary function and the right-hand side to find the particular integral. And we added the two solutions together in the end.